Hi folks, this is our eighth overview video, giving you the hopefully the tools you'll need to be able to handle assignment number 8. This is actually, it's interesting, this is a simpler, conceptually simpler section than much of what came before. It's almost like they took things in the wrong order here. So the topic for this section is simple interest. And it's funny. The idea of interest is something that's so familiar to us these days that we don't honestly think much about it. But it wasn't that long ago that interest was considered, if not illegal, definitely immoral. In certain places, it was literally illegal. So it was considered wrong to charge people money to on a loan. And I want to convince you that that's not a good idea. That's not really smart because a lot of our modern financial system relies on the idea of charging rent on borrowing money. So yeah, the word rent is what I want to focus on for a second. A friend of mine recently was putting in a deck, and he needed to get this tool that's used to drill great big holes into the ground. It's essentially a drill, but it's a big one, and it's gas powered, and it's called an auger, right? And so this thing will drill a hole that's like a foot around into the earth. You make the big hole like that, and then you fill that with concrete, and you can anchor posts into it and whatnot. Anyway, you build a deck from there as your sort of foundation. So that device, this earth auger, is not something a normal person owns. If you're a contractor, maybe, but so you can go to places like the Home Depot and you can rent that tool, and that's a perfect setup, right? The Home Depot owns the tool. It probably costs them many thousands of dollars to buy that sucker, but they get their money back out of it by renting it to people who need it. You need it for a day, and then you give it back, right? So it's $50. Well, let's just think about how that transaction works. You go to the Home Depot, you leave $50 poorer. You pay them the money for the. In fact, you probably pay them a little extra, a deposit on the sucker, but you essentially you pay the rent then, and then you bring their tool back to them a day later. So you paid them for the use of the tool, then you took the tool and you used it, and then you returned the tool. They've got their tool back, and they've got the $50. What have you gotten out of that transaction? Well, your deck is now on its way to being constructed, right? So both parties feel like they got value out of that transaction. Now, what if instead of a physical tool like that, you think about money as literally being a tool? Is there a situation where you can think of, gee, if I had this money, I could do things with it, and that would make me more money, or maybe give me value in some other way? Lots of cases like that, because money can be traded for real things, right? So, a different way to approach that whole transaction would have been to say, I need to borrow $5,000. Borrow the $5,000. Go buy your own earth auger, use it for a day, then return it, get the $5,000 back, and pay. But that would be dishonest in a certain way. You're putting use on the tool and then returning it to the person you purchased it from. So anyway, the point is, having money in your hands is a thing that is of itself valuable. The possession of money can be used to create more wealth. So does it make sense that you should have the idea of paying rent to somebody else if you borrow their money for a period of time? I would say yeah. All right, so this idea that money lending and charging interest on loans was immoral actually has a name. It's called usury. And we still use that term today when companies or banks, often credit card institutions, charge interest that is exorbitant. If you get a credit card, I'm imagine many of you do have credit cards. Be careful about the way you use them. If you maintain a balance on a credit card, you can often end up paying 20 to 24% interest on that money, and that's usury. that's plain and simple usury. Um, Worse, that kind of interest is known as compound interest. So you don't pay off your credit card balance, they add interest to the balance, and the next time they calculate interest, you're paying not only on the stuff that you charged, but also on the interest you got the last month. So if you don't keep up with paying those things off on a regular basis, you end up paying interest on the interest. What we're doing first in this section is the sort of more straightforward setup where you have not interest on the interest, but simply interest on the amount of the loan. Simple interest, it's called. So what should simple interest depend on? Well, there's really three things. There's the amount of time that you're going to borrow the money. So the term of the loan, that's called. There's the amount of money that you borrow. That's usually written P for principal, but it's the amount borrowed, or lent if you're on the other side of this transaction. And finally, there's a number that people usually call R, or rate. And that's the interest rate, often expressed as a percentage and often expressed as an annual rate, but not always. You watch out for this in, like, there's a sort of criminal activity called loan sharking where people will give loans usually to people that are not particularly creditworthy so that the banks wouldn't give them the loan. But the loan sharks, these are the kinds of guys that will like break your kneecaps if you don't pay them back, and they charge simple interest most often, but it's like 50% for 2 weeks. It's a very large percentage over a very short span of time. 50% for 2 weeks would be, gosh, 2,600%. No, 2,600% if you did it annually. So the rates we typically use are annual, and normal loans are in the range from a couple of percent to in the teens. Credit cards didn't go above that, but I don't know if I should have written annually because that's just the normal situation, but you can, how about if I just say usually? Can I spell usually? Usually annually, but it can be other things. All right, so what do you do with these three quantities to figure out the interest? You multiply them. So the interest is the principal times the rate times the time. I don't know why I mentioned the things in the order that I did. It's usually P, R, T. And I mentioned before when we were doing exponential functions the formula P e to the RT. This is, similar, and we're using the same letters for the same meanings. Okay, so if you take a loan that's going to charge interest, there's sort of two ways to go. You could do like you do when you borrow the tool, pay the interest up front, pay the rent on the money up front, and then take the money with you. But if you're doing this with money versus an earth auger, well, what it means is you end up taking less money than you thought you were borrowing away. The interest has already been returned to the person who you're borrowing the money from. For instance, suppose just a simple example, I borrow $1,000 from a loan shark, and he says it's going to be 10% for the day, and I say, fine, that'll work, and he hands me $900, right? Because he's keeping his 10% right up front. Well, that's one way it can happen. The other way is you think about paying it all off at the end. So the guy loans you $1,000, and he says, when you come back tomorrow, it's going to be $1,100. You can do it that way too. in the scenario I just said, what you've got is this amount that's due in the future, which is, think about what it is. It's the principal of the loan, the amount borrowed, plus this stuff we just figured out, the interest. And I just want to re-express that slightly because I is the same as PRT, right? So P plus PRT. And finally, noticing that there's a P in both of those, you can factor it out. So you get P times 1 plus RT. All right, so perhaps an example is in order. Suppose we borrow we're borrowing $5,000 at a 6% annual rate, and we're keeping the money for 3 years. So at the end of 3 years, we're going to pay it back and pay the interest at that point. What is that? Sometimes called the future value of the loan. Well, it's the principal plus the interest. One way to calculate this, is pretty, I think a reasonable way to proceed, is just work out what the interest is and then add it to the principal. So to do this calculation, we need to know what I is, and I is PRT. Oops. Now, what are those things? What are P, R, and T? P is the $5,000, the amount of money we're borrowing. R is 6% per annum, and I'm measuring the time in years, so that's fine. We need to multiply times 6%. Now, remember to turn that into a decimal if you're doing this kind of thing, 0.06. And then we also need to multiply by the term of the loan, or how long we're keeping the money, and that's 3 years. So we should, well, I guess we have to turn to a computer here. But, well, not really. Just use it as a calculator, to be honest. The number we need is, come over here and click in the thing, 5,000 times 0.06 times 3. Oh, it's $900. Okay, so that's what the interest is, and the amount that we'll owe in the future, this A, is the principal plus that interest. So I think of what I just did here as work that I might do on scrap paper. Figure out the interest. The actual amount of A is the 5,000 plus the 900, or $5,900. Okay, well, I see. Sorry, I failed to transition back to where I was writing that stuff, but I was speaking through it, so maybe it's okay. We figure out that I is 900, and so the A is 5,900. All right, well, now we're going to look at sort of the other side of the coin, which is the kind of loans where the rent on the money is paid up front rather than at the end. That is, these are called discounted loans. So largely, it's the same idea. It's just sort of a matter of perspective. Do you think about the rent of the money on the money is paid at the end, or do you think of it as being paid up front? So some terminology. If you have a discounted loan, there's this idea of maturity, which is basically just the point at which the loan period is over. A good way to think of this stuff is probably you're thinking that you're working from the perspective of the lender rather than the borrower. The lender wants to know, when do I get my money back, and exactly how much am I going to get back? So that amount that you get back is called M, most often, because it happens at maturity, which is the end of the loan period. So the borrower needs to pay back that money at that point. Now, the amount the borrower receives from the lender when the loan is actually issued is smaller. That amount usually is called P, proceeds. And the term discounted that I'm using up here, well, that comes from this idea. The difference between M and P is called the discount. So, can we work out a formula for that sucker? Well, yes. The discount is basically the same calculation we did for the interest before, except we use M where we use P. So it's M times the rate times the time. Now, since I said the difference between M and P is D, if you really want to figure out what P is, it's M minus the D. And we can take that one step further and say, well, if D is MRT, this thing is M minus MRT. And like before, you can do some factoring. Pull out, see how there's an M in both of those terms. Pull it out, and you have M times 1 minus RT. Now the only the principal difference here is just the way you refer to things, not really what's going on. But in this case, you'd call R the discount rate, and you'd use subtraction to figure it out. But it's like knowing what you're going to be paid back at the end of the loan as the lender is kind of the important thing. So M is the number that you use for that. But that's usually what would be called A in the other scenario. So if you wanted to emphasize what's the amount at the end of the loan, this is the way to do it. And that means to figure out how much the proceeds should be sent to the person or given to the person at the beginning of the loan, it's going to be a smaller amount. Maybe that makes sense that it would be subtracting something from 1. This is going to be a number less than 1 that we multiply M by. All right, here's an example of a discounted loan scenario. And the common problem with the discounted loans is you know how much you're going to have to pay back, but you don't know without doing some calculating what you're going to get as the proceeds, how much money is going to be in your hands at the end of the transaction on the day you make the loan. So let me just read this to you. Bob takes out a discounted loan at 12% discount rate for 6 months. The maturity value is $10,000. Okay. So M is $10,000 and R is 0.12. The term of the loan is 6 months. You probably want to think about the term of the loan as being half a year, right? Because time is in years. This 12% is very likely an annual rate. I didn't write it, but it is. Okay, so he's borrowing this money because he wants to buy a tractor that costs $9,800. Will the proceeds of this loan be enough? Well, let's see. What are the proceeds of the loan? The M value is the 10,000. The discount is M times RT, right? And that is going to be, what are the pieces of this? $10,000 for the M. The rate was 0.12, and the period of time, I'm going to write it as a decimal, a half a year ago, 0.5. Gee, I guess I'm going to calculate again, so let's get that into GeoGebra. What is that amount going to be? 10 grand times 0.12 times 0.5. Oh, that's $600. Okay. I gotta watch myself get this transition back. Yep. So this is a $600 discount. Now that means that the amount he's actually going to receive, the proceeds, is our maturity value minus the discount, which is 10,000 minus 600. That's 9,400. That's dollars. I probably should have put the dollar sign in front of each of these. But anyway, does he have enough? No. So you could either say, okay, let's renegotiate the loan. I really need to get more than this. I need to get $9,800 at the end. But or you could just say, well, I'm going to have to kick in the extra $400 that I need, from my own pocket. But in any case, once you figure out what the proceeds are, in this case, we'd say, nah, he doesn't have enough. All All right, I think that is. Oh wait, there's one last thing I did want to do, which is to show you something in the textbook. In the section on simple interest and discount, there are formulas we just went through. There's a little table in the back of it where it kind of collects all the information you need for this stuff. There we go. This is the very last thing. Oh, the section 6.1 summary. It quickly shows you the formulas you need for both a future value type loan with, or sometimes, yeah, that's right. They call this accumulated value. Probably that's why they use the letter A, accumulated value, versus a discount and proceeds formulation. These, well, I think I've already said this, but yeah, they're the same idea, just different perspectives on it. All right, well, that brings us to a close. Have a good rest of your day.